Welcome to Bearskin hats using guard clauses for more robust programming. I have to warn you all, I did expect to be in the last time slot today. So the last time I clocked this, it took us maybe 30 minutes. So we'll either have lots of time for Q&A, or you will get to see the second half of that other session. My name is Cristos Lianides-Chin. I'm a platform architect at Codus. I've been working in FileMaker for a little over 10 years, which means I got into the good time when it was the FileMaker 11 to 12 transition. I can proudly say I've never had to do an FP5 conversion to this day, and I hope my luck holds. I really enjoy cooking and sailing. I live in Portland, Maine, right by Casco Bay. And I really don't like to work any harder than I have to when I'm programming. So there's a few things I'm hoping people will take away from this talk today. If you're a new developer, I want you to know that you can use emojis in comments. Yes. And it will drive your tech lead insane. For intermediate developers, I want to make sure that you get a foundational understanding of what a guard clause is, how to recognize it, how to spot when you might want to convert something to use guard clauses instead, especially if you're retrofitting older code, or even if you're writing something from scratch. We'll also cover what the try-catch pattern looks like. This is a very common pattern in other programming languages. We have options for implementing it in FileMaker now, but it's not something that I think is really well distributed throughout the community, and hopefully this will start to change that today. If you're a tech lead, we will touch on some ways that you can apply guard clauses and the try-catch pattern in more complex scripting scenarios. They can be really powerful there, but they can also be really annoying there. So I think it takes a fair amount of judgment to know when is it going to make things better or make things worse. Also, just hopefully, the more we see of each other's code, the better we get to understand tools that we use, including FileMaker, and just generally build knowledge on best coding. So in scope for today, like I said, guard clauses and single pass loops, or the try-catch pattern. Topics that I've seen put together with these in a lot of places throughout the community that I'm going to try not to get into the weeds on are things like error handling or transactions. I think error handling is a really, really important topic, and it plays very, very well with the try-catch pattern. Really, to unlock the power of both, you can put them together and it just becomes one of the most useful tools as a developer in FileMaker. My friend and colleague Robert No did a talk with DigFM on error handling patterns. I would strongly encourage you to go watch his talk. I think it's about an hour long, and it is an hour well spent. For transactions, if you were, like me, lucky enough to get into Barbara and Alo's modern FileMaker transactions this morning, that was really excellent. I think it covered a lot of stuff, some of which overlaps with the things we'll be talking about. So the video is obviously not out quite yet, but keep your eyes peeled because I think it's excellent content and it does complement this. So what is a guard clause? What does it look like? You've got a script. At the top of the script, you're doing something. At the bottom of the script, you're doing something with that. So I passed in a parameter, and I'm going to use that parameter in some way to look up a customer or place an order or get a price or make something happen. But it's not always safe. Sometimes you don't get a parameter. That means your requirements aren't met. What happens if I try to place an order and I don't have a product ID? What happens if I try to get a customer's address, but the customer ID doesn't match anything? Or it's formatted wrong. I got a UUID and my script is using integer lookups. So a guard clause is a way of exiting early. So it checks to say, okay, do I have everything I need to run this next block of code? If not, I don't go any further. I just bail. So we're going to take a quick look at a very simple version of a guard clause. This obviously is a simplified model just for this talk. So we're going to call an order the combination of one customer and one person. Obviously, in the real world, orders are much more complicated than that, but we want to strip this down to the bare essentials. Let's switch over to the demo file. Is that legible for everybody? Great. So this is how you might see that kind of conditional requirement check done with an if block. So I've got a check to see if I have both parameters, a customer and a product. If I do, then I'm going to go ahead and create my order object. If I don't, then I'm going to create an error. And I'm sure you've seen examples like this. I'm sure we've all written examples like this. We've seen it in lots of places. And when it's this simple, when it's just a few lines, there's nothing wrong with this. If I have 200 lines in my if block, I might start to have a little bit of a problem. If I have several checks, which is one of the examples we got, I might have more of a problem. To do the same thing in a guard clause, there's our bearskin hat right here. So anytime you're staring at one of these code examples, watch for that little emoji icon. I'm doing my check not to see if it's safe to continue, but if I need to exit. So if I don't have exactly 2 parameters here, then I'm going to exit my script. And that's all a guard clause is. It's not complicated. It does require a little bit of a mental shift. You'll note that in this example, I'm checking to see if my parameters equals 2. This is my continuation check. Is this the happy path that I want to continue going down? Whereas when I'm writing my guard clause, this is the inversion. This is the not equals check to see, do I need to exit? If I don't need to exit, then I assume that it's safe to. So let's talk for a second about a slightly more complex ordering process. And again, this is still just the simplified version for this talk. This isn't anything like what it would in a real application. But I think it'll help illustrate where guard clauses really can help with your real world. So we're going to run a few different checks to validate that an order is safe to proceed. We're going to check that we have the object or have the product in stock. We're going to check and make sure we can get it to the customer. We're going to get a personalized price for that customer. Maybe they're a loyalty member. Maybe they're in a different tier. They're in the gold or platinum tier or your e-commerce site. And then if we're satisfied on all those other conditions, then we'll go ahead and place the order. So this is that process with no checks in it. This is the code version of that flowchart we were just looking at. I'm checking my stock at the top. I'm checking to see if I can deliver it. I'm getting a personalized price. Then I'm going ahead and placing the order. And if I add checks to that in the way we were seeing it first with just if clauses, you can see where all my checks are. But you can also see that this block of code is starting to point at me. And that can be a real problem. Here, it's not that bad because each of these checks is like 2 lines. If these weren't in subscripts, if this was one monolithic script, I could have 50 lines in the first check, 50 lines the second, 100 lines to get the customized price. And it could get really hard to understand where I am in the code, what I'm looking at, to debug what happens if I get an error message at the end. And you can see, even just with this being enlarged, how much scrolling there is. So if I'm looking backwards and I say, okay, I got a message with insufficient stock of the product. Well, I'm going to put my cursor right here and hope I don't move it. And I'm going to scroll all the way back up. And are we at the right place to check it? No, I still got a lot of white space there. Is this it? That doesn't sound like the error message I got. Okay, this is probably what I was looking for. So that's the arrow pattern. When your code starts to get indented heavily because you've got several consecutive checks, one is nested inside the other, it really can be a challenge. It makes maintenance hard. It's not just that we don't like it as developers, though believe me, I hate having to debug that. But it costs our customers money. It costs us time. It makes it harder for our associates to work on that code with us because they're not going to be as familiar. They're not going to know what to jump to. They don't have the whole thing loaded into their head. So I have to train them on the idiosyncrasies of this particular piece of code. And this is where the guard pattern starts to pay off. So I have the same set of checks here. Almost all of them on scene. So again, if you look for the little bearskin hat, you can see that we're checking all of the same conditions that we were before. I'm starting with, are my parameters filled? I'm moving on to, do I have it in stock? And if I don't have it in stock, then I exit my script right here. It's not safe to continue. Why run the rest of it? If I don't have my parameters, I exit my script up there. All of these are points where we know there's a conditional here. Do we continue or do we not? And what that results in, if you scroll further down, that's almost all of my guard clauses. Here is the meat of that logic. This is what I'm actually trying to do in that script. It's concisely together. It's all indented to the same level. And it's much easier to read. Even just for me, never mind somebody I'm going to hand this to when I go on vacation. So why do we use guard clauses? They make for more readable code. The arrow pattern is an anti-pattern. It's something that we should be trying to avoid if we can. It's not always completely possible. But we know that when we're looking at code with the arrow pattern, there's probably a better way to do it. Guard clauses let us return early. If I don't have my parameters, I don't need to run a computationally expensive database check to look up a customer. I can save the server that workload. I can save my customer or my user the time it takes for that lookup to happen. I can just say, nope, this isn't going to work. I know it's not going to work because I don't have everything I need. So let me just get out of it early. And if you need more reasons, like I said, this is not something you need FileMaker. The guard pattern is something common in all programming languages. And so I'd recommend, once you get the final version of these slides, you'll be able to get these links out of the PDF or the keynote. These are some resources I would recommend if you wanted to understand more about the guard pattern outside of FileMaker. So when we looked at that first example with all the nested ifs, would it work? Absolutely. That code would be 100% safe to run. I wouldn't have any qualms about shipping it to production other than my own personal code. But as Robert Martin wrote in Clean Code, it's not enough to work. First, you make it work. Then you make it fast, and you make it good. Good code is clean, readable, and understandable. And that brings us to some different ways to apply the guard pattern in FileMaker. So if we're looking at that same process that we started with, checking our stock, checking the delivery availability, getting our personalized price, making sure we're all the way through those before we actually place the order, we can do that with the exit script pattern that we were just looking at. All right? But here I've got 4 places, more than that, 5 places. I've got more than a few exit script steps in here. I'm writing this twice. That's another code smell. Sometimes, is that the right move? Absolutely. But I'm going to look at this as a code reviewer and say, I wonder if there's a better way. Is anybody familiar with that better way? Someone want to shout out what it is? That is my solution too. So I first learned about this from a Soliant blog post, I think, when I was a junior developer myself. But this is a concept that's been around the community for decades. It's not new. And the idea is that you open a loop, and then at the very end of that loop, always exit. So that means whatever code is inside of this loop is only going to run once. We're not going to get stuck into a pattern. We're not trying to iterate over it. It's really just there as a structure for convenience of the program. It has no function on the code. We're not changing the control flow logic for the way this particular script works. We're just giving ourselves a blank place between loop and end loop where we can put all of our steps. And inside of that section, instead of exit script, I can use exit loop if. So if I want to check if I have a parameter that I need, I can do that in one calculation. I can build an error message into that. Is out of scope for this particular talk, but I can build a JSON object that is an error object that will be part of my script scope now, which means I can pass that up and down to the calling script to say, hey, I failed. Here's where I failed. Here's the record I was on. Here's the reason that I had a problem. And that means the calling script can then do something with that. It can either say, that's a fatal error, I'm going to abort the whole process. It can say, yeah, I don't really care. I'm going to accommodate that in this way, and we'll just keep going. That ability to set your error object is one of the strengths of this, because I can do that in the same step that I'm running my check. And so even at this enlarged font size, you can see that I can skim down and see in the one line of code, what's the error message? If I'm working backwards, I need to find my error message and figure out what process that failed. Well, I see insufficient stock on hand right here, right at this level. But I also don't have nearly as much vertical scrolling to do. Because if you look at the exit script version, I can still set an error object here. But it's taking me 4 lines of code to run my check, create my error object, and actually do my early return to exit. Here, I have 1 line of code that does all of those steps at once. This does take a little practice to be able to read fluently, but it is a much more concise way of doing it. There's another key difference here. If I exit the script, then nothing else in the entire script will run. So if I opened a new window and I exit my script, then that new window is still hanging. That means I've changed the context on the calling script. It may not be able to safely do whatever it was going to do next. With exit loop if, what happens when you exit a loop? It jumps down to end loop. Then it picks up the rest of your script. This means I can have error handling code here. Maybe I want to log the error here. Maybe I want to send an admin notification. Maybe I want to run some cleanup steps. Oh, if there was an error, then revert whatever other records I might have been touching, try to restore the system state. Or notify this web API that, oh, we rolled this thing back. I then also have cleanup steps that can happen no matter which path my code takes. If it's successful, great, close the window. If it failed, great, close the window. I don't have to write close window twice. I don't have to keep track of all these things. I can do it in one place because I know that this finally code will run every time. So this is an implementation of the try-catch pattern. This is an example from Python, where it's try-except instead of try-catch, but the pattern is really the same. So what this code is doing, at the top, I have basically a Python list of numbers. Not all of them are numbers. I'm going over all of them, iterating through that list to say, if it's a number, process it. Oh, if I can't process it because it's not a valid number, then skip it. But don't stop iterating. This is one of those places where try-catch is really, really useful because sometimes you have a list of 100 things. You don't want to abort the entire process if 1 out of 100 things doesn't work the way it's supposed to. And you can see that down here in the example output code. Process number 10, process number 20, hit something it couldn't handle, we'll just skip over that one. Pick right up again on 30. If I were doing exit script as an equivalent here, when I hit that letter A, I wouldn't get through the rest of my list. I wouldn't have any other option for handling. With the single pass loop, I do have an option. I could say, if you hit any error, consider it a fatal error, jump down to the bottom, exit out of the script, don't continue the process. But I can also say, if you hit an error, that's fine. Remember that it was an error, or just notify someone, and then move on to the next item and keep working. And iterators are a pretty common place to do this sort of thing, but there are other coding structures where that's useful as well, where you want to be able to have more control over the flow through your script. That if it hits an error, not all errors are fatal. So this is what that looks like similarly in FileMaker. This is the single pass loop. And you can see here, my yellow section, that's my try. I'm going to just open my loop. I've got my exit loop if true at the end, so I'm only running through that once. Anything I put in there, I can put an exit loop if step afterwards, and it will jump out of the try block and move on to the catch block. It's red one. If there's an error, I can catch that error and do whatever I want with it. And then finally, I can run my cleanup code. Now, if you were in Barbara and Ala's presentation, you know that there's another way we can do FileMaker now that is new as of, I think, 19.6. And that's with the transaction steps. Let me just switch back and forth there again for a second. Try, catch, finally. Try, catch, finally. The pattern here is exactly the same. The implementation is a little bit different. I'm opening transaction at the top, and I'm committing my transaction at the bottom. Anywhere that I want to bail early, I have a revert transaction step instead. Again, much like exit loop if, revert transaction lets us have a conditional check and build some kind of value, whether it's a simple text string or an entire JSON object. Pass back up the call chain to say, this is what happened, where it happened, decide what to do with it, parent calling. There are some differences in these implementations. If you're in a single pass loop, bail, it doesn't impact the transaction. You can see error messages in the first level of the script workspace, although, like I said, it does take a little bit of practice to be able to read that fluently. Whereas if I'm doing the transactional version, it does give me more bang for my buck. It reverts the transaction as part of that, early return process. I don't have to have separate code down here to revert my transaction instead. But it may not fit all situations. So this doesn't work if it's in a subscript. If this parent script is calling a subscript and the subscript has a revert transaction, it's not going to behave the way that you intuitively might think it would. If I have a non-fatal error, maybe I don't want to abort my entire transaction. Maybe I want to keep processing the next item in that list of 100 things. I can't do that if I'm reverting the transaction when I hit and can't see the error message without clicking through, affecting the properties of that revert transaction step. You can see that it is a bit cleaner. I have my condition, and it's clearly spelled out. But the error message itself, pull up who that example came from. I'm going to go through here and check out the calculation for my error message. So if I'm working backwards, I see a log entry that has an error in it, or a user called me up on the phone and said, hey, I'm getting this dialog box, and it says missing ID record. What the heck is ID record? I'm going to have a harder time looking through this piece of code to figure out exactly where that error is occurring. So like I said, different implementations, they both have their strengths. They can both be used for different kinds of situations. It's not wrong to do transactions. It's not wrong to do it with single pass loops. But recognizing when is the right time to use which implementation is important. So I mentioned that you can use try-catch inside of other structures. Let's take a look at one of those structures. We're going to expand on our earlier example a little bit where we had that one customer plus one product equals one order. Let's say I've got a list of products. So I've got one customer, but they're ordering 10 items. I want to know which ones I can place an order for. Maybe it's available in the store and they opted for 2-hour pickup. And I want to know which things I can't successfully complete that order for. But I don't want to abort if I hit an unorderable product. I still want to get them the other, let's say there's 10 things. If there's one that can't be ordered and 9 that can, I definitely want to sell them those other 9. I don't want to abort the entire process. for 1 second here. So this is that script. I'm going to reduce the font size a little bit here. I apologize if this makes it a little harder to read towards the back. Let's get rid of our palette over there. So here we still have our initial parameters check. And we are going to bail early if we don't have the things that we need. Even before we get to the iterator, there's no point running this loop if I don't have a list of products. Similarly, if I have 10 products but no customer, there's no point going any further. So I've got my single pass loop starting basically as soon as I'm checking my parameters. But now I have another loop out of my single pass loop. This loop is my iterating loop. This is where I'm going over each product and I'm pulling it out. I happen to pack it into this snippet. Obviously, there's a lot of ways you can write your iterator. But basically, all this is doing is it's saying, get the total number of products and go through it that many times. Not time for a break quite yet. And then for that product, or for that loop iteration, get that product. On the third loop iteration, get the third product out of the list. Now I've got an inner try. I have another loop. And you'll note this is starting to get a little pointy. This is not, the cleanest, least indented code that we could possibly write. This is one of those places where it's a judgment call. Is it better to write it this way? Is there another way you could write this that would be? But inside of my inner try, now it's basically the same code that we looked at earlier. It's running all of its checks in order. It will bail out of any of them if it hits a problem. And here's my inner catch. But keep in mind, I'm still inside of that iterating loop. I'm going through these 3 steps for each product. If there's a problem, all right, I can't place an order for that product. That's fine. Add it to the products that can't be ordered list. Clear my error out. Move on to the next product list. Then at the end, I should have 2 lists. I should have a list of things that I can place an order for, and I have a list of unorderable products. So with the list of things that I can order, go ahead and try to place that order. Here's another inner try. Keep in mind, we're still inside of one big try at the very top. On this inner try, is there anything in that list? If not, don't go any further. Here's another guard clause. I've got enough stuff to place those orders. Great. Pass that on to the ordering script. See what comes back. If it wasn't placed, well, there's another problem. We've got to report an error. What do I do if there's an error? It couldn't place that order. Well, I've got this whole list of products that I couldn't order already. Why don't I just add it to that? Here's my inner catch where I'm checking. Did I get an error here? I did. Great. Let me add that product to the unorderable products list. And now I finally have the full list of things that needs to be handed off to a human, whether it's the customer or an internal staff person, to deal with and say, okay, we couldn't fulfill these for 2-hour pickup. Let's email the customer and say, hey, do you want these shipped to you? Or do you want to cancel them? Or have somebody from customer service actually go out on the floor and confirm, yeah, you actually don't have that in stock, or maybe your stock system isn't perfectly reflecting reality. Stock system never do that. And now I've got my outer finally and outer catch. So I've finished my parent loop, the big try catch that was over all of this. I check for any errors, and then I close my window to reset my context. This combination of nesting try catches within other try catches, this is one of the things that makes this such a powerful pattern. But as you saw, it can also make it a little hard to track. So it is very much something that you need to consider carefully and say, is there a better way to do this? Is this the right way to do it in this situation? And sometimes there is a better way to do it, but other constraints on the project, time, money, availability of developers, that can't do perfect, but you can still do something pretty good. Before I move on to calculations, I guess, any questions about the script stuff so far?
There was an exit script in your loop.
That might have been just a copy paste error on my part.
Okay. I was hoping that was the case.
Yes.
Line 50.
That one. Yep. Yep, that's definitely a copy paste error. Thank you. You have just helped improve the final version that we uploaded. Any other questions so far? Going once, going twice. Great. Oh, I'm sorry, go ahead.
On the transaction version, and I don't have a very good understanding of transactions as of yet, but does the revert transaction, does that work like the exit loop? It then jumps to the bottom of the commit.
That's exactly right. Yep. So when you hit that transaction step,
It skips all the rest
everything
of the
else.
Okay.
And that's why it's equivalent in terms of your control flow to the single pass loop with the exit loop. Those are the only two steps I know in FileMaker that will actually do exactly that. Fail early, but leave you within the script.
I was also thinking you could do more of a hybrid approach there too. Do the loop if, and then in your error trapping, you could do the revert. So you could start out that way.
And honestly, because I'm not used to the transaction steps,
Neither am I.
that's exactly how I would approach it.
Yeah.
Any other questions? So this brings us back to scripts versus calcs. So we just talked about how in the scripting engine, exit loop if and revert transaction both have the same function of exiting one scope within the script, but leaving you inside of the script itself. Calculations don't have that in FileMaker. There is no functional equivalent that does the same control flow operation of, okay, at this point, I will exit and continue on somewhere further down. But we can still have a similar pattern. So this is a case statement. In a case statement, FileMaker checks to see what's the first true condition. And if I hit that condition, I will execute that and ignore the rest of the calculation. That is functionally equivalent to, bailing out. It's not exactly the same. So it does take a bit of a change in your mentality when you're switching from scripting to calculations. You want to apply similar kinds of patterns. But you can see that I still have my little Buckingham Palace guard all throughout this calculation. And I can still improve performance on the calculation by running the easy, cheap checks first. If I have an empty parameter, well, that's just a little bit of thing in memory. That was really quick to check. And if I get that, I know there's no point going on and running the rest of the code. Whereas I got to do a lookup, especially on a related table. Well, I only want to do that if I really have to. But if I do that and it doesn't look good, then it looks like I'm missing a step there. I might have cut that out by accident. But I want to return an error because that's maybe that's a business logic condition where we shouldn't get a valid result back. That record is somehow in an invalid state. And then finally, if I haven't been blocked by any of the guard checks, I want to actually do my calculation at the very bottom. So, like I said, it's a little bit inverted. This isn't my try block at the top. This is actually my catch block. So instead of try, catch, finally, I have catch, slower catch, try. But because of the way case works, I do still get to return it. I don't run this final block of code unless all of my guard clauses have already run and confirmed it's safe to proceed. So takeaways again. If you're a new developer, use emojis and scripts. You can use them in calculations too. It's a little funky on Windows. It's not as much fun there. If you're an intermediate developer, then hopefully you understand when you're looking at a guard clause now, or better yet, when you're looking at something that should be a guard clause. And hopefully you've got some beginning of understanding of what does the try-catch pattern look like? How can I implement this in FileMaker? How can I do it in a script versus how can I do it in calculation? And if you're a tech lead, then yeah, I mean, you can nest guard clauses, you can nest try-catch patterns, and it can be really powerful. It can also be really obtuse. So do it with caution. But being able to do something like that, that is part of the coding practices. Sometimes it's important to be able to say, yep, I'm iterating over something, and maybe it can't be done within a subscript for one reason or another. Whether I don't have the time to refactor it, or some operation is occurring and the data is just not being passed reliably because it's too big. So there are reasons to do that, and it can be a best practice, but it does take judgment to know when to use. But like I said, I promise we have plenty of time for Q&A. Anybody have other questions that haven't come up so far?
So that last example you showed with the case statement and the calc engine, would it be safe to say that there's not really a try block? It's kind of just a catch and then a finally in this case?
You could certainly look at it that way.
Okay.
Yes. Like I said, it's not completely analogous. So I think depending a little bit on how you're setting this up, because you could run a case or an if in here too.
And that would be that try.
Yeah.
But there's not a finally because first cases you won't.
That's right. Yep.
Okay.
Yeah, so I think it's Ruby has a slightly different pattern. They've got a success version. So try, catch, success, finally. This is probably a little bit closer to the success version, but it's not really worth trying to, identify exactly how it bends into that pattern. The really important bit is you've got your guard clause at the top, so you have your catches at the top, and then you have your happy path at the bottom.
Okay, thank you.
Other questions? Anybody feel like they got one of the takeaways here? Oh, please.
I just wanted to say this was fantastic. I didn't even know I needed to know this stuff, so thank you guys.
Thanks to each others, because like I said, this is a really important, powerful way to think about your code. But in the community, there aren't a lot of resources to teach, especially new developers, about how to use it. And so I think it's important to know, what does it look like by itself? And what does it look like when you combine it with really good error handling, with transactions? Because the combination of these things is, exponentially than any one of them by themselves. Please, Richard.
I was just going to say that, I guess it's a successful session when I really want to go home and rewrite all my script.
Yes, 6 months ago, Cristos also wishes he could, I wish I could rewrite all of his scripts.
A couple of years ago, I used the emojis, and I found that they were working well on my Mac, but not on Windows. Do you have to have the right font set, or?
I think it has to do with Windows implementation of Unicode.
Okay.
So I'm not positive if fonts alone are enough, but it looks like
Yeah, it's just the issue with the Unicode. So it'll come through as like a square or like a square with an
Yeah,
F.
that's what I ran into.
It doesn't pull in from the Apple library for the.
Yeah.
Wow.
There's another, oh, please.
So we have no error guard system at all, of course. But you have a best practice for track of where errors come and like a history log of some sort?
I do. I've been told that mine is maybe a little over the top. I use custom functions. So I have a set of custom functions that basically I'll call when I'm throwing an error.
Okay.
So I can put a quick example here. So with my custom function, it looks a little bit more like if So I've got my condition, my message, and then if I want, I can throw some extra data in, like which product was I on? Hopefully I don't have too many.
There's JSON set elements missing. Right.
Yep. So this is what it looks like more in my actual code. That custom function is actually a pointer with a set of custom functions behind it, and it does things like grabbing the script section, get last error detail, get last error location. So I don't have to type those all in by hand every time. But it does mean importing that set of custom functions. Proofgeist, I think, also uses a similar approach that Barbara talked about in her presentation. Again, I would recommend Robert No's presentation to DigFM. He goes into error handling in depth there, and I think he really covers what I would consider the fundamental best practices. Other questions? All right, anybody want to know how to write emojis, or have you all figured it out already?
One thing out.
Yeah.
If you're, I guess it doesn't work, but on the Mac, emojis work everywhere.
Yep.
File names, script names, calculations, everything.
Yeah, it's pretty fun. It can also, like I said, be a little annoying if you're the tech lead and you're doing code reviews.
Stumble across that completely accidentally. The keyboard command that brings up the dialogue for the.
Yeah, on I think most Macs by default it's the FN double tap.
Yeah. Alex, what was that?
Exactly. All right, well, thank you very much for attending the session.